Good afternoon and welcome to our webinar presented by the Chemical Coaters Association International and Products Finishing Magazine. My name is Tim Pennington. I'm the editor of Products Finishing, and we're pleased to bring you this webinar titled Maintaining a Quality Finish, Part 1. It's be a three-part series we're going to be running over the next couple of months, but this is Part 1, Hanging Methods and Pre-Treatment Solutions. First, we want to thank our sponsors for today's webinar, Therma-Tron-X and Hubbard Hall. As a reminder, we'll be taking questions from anyone who's viewing the webinar today live. You can ask those questions at the end of our presentations, and the presenters will be happy to answer those for you. Right now, I'd like to introduce our presenters and get it started. The first speaker will be Bill Oney, who is sales engineer with Therma-Tron-X. Following him will be Larry Inslee, who is a technical service manager with Hubbard Hall. And to get the webinar started, here's Bill Oney.
Well, good afternoon, everyone. My name is Bill Oney with Therma-Tron-X, and what I will be discussing today, actually, there we go. What we're going to cover today is rack cleaning considerations, basic and best design review, hook storage and ergonomics, hook and rack design key elements, and then we'll discuss some case studies regarding racking and fixtures. So to start off, I just want to explain what transfer efficiency is. Transfer efficiency in powder coating is the ratio of the quantity of powder deposited on the part to the quantity of powder directed at the part. Transfer efficiency is given as a percentage, with 100% being most desirable. So here are some rack cleaning considerations as you're building tooling and have tooling within your facility. So you need to keep in mind that every system is different. You also need to keep in mind that when parts lose conductivity, poor grounding will take place and poor products will be the result. When parts become difficult to load and unload, basically taking a part and putting it on a hook, if the buildup is too great, this will cause problems for your workforce and result in lost time. Smaller diameter materials are actually preferred as opposed to larger diameter, creating less shadows and less Faraday cage. You want to discover a process if you are going to strip your paint hooks that removes all ash. Ash can get into the wash system and create issues within a washer plugging nozzles, which can result in transferring onto the parts and causing rejects. Also, you might want to consider having a hook or a fixture that may hide the ground point. For example, if you have a rod that you can put up inside of a tube and bottom out on the end of a part that the ground is completely hidden, that would be most desirable. You also want to engineer racking solutions that minimizes cleaning cycles. And what I mean by that is you want to create less surface area wherever possible. So if you could, instead of using flat pieces that are facing the paint operator, turn those 90 degrees and have them face away, the buildup will be less on the fixture, therefore getting more powder or paint on the fixture, on the part versus the fixture itself. Some of the methods of rack cleaning are chemical, sand bath, salt, inline furnace, water jetting, shot blasting and wheel abrading, or burn-off. Some of the advantages of performing coating removal in-house are basically the convenience. So you have an oven in-house that you can use. You can take the fixtures at the end of the day to the oven and you can utilize that space. You can schedule accordingly because you'll need less fixtures that you can use them day in and day out because you'll have them ready the next day when you come in. So lead times are reduced and tooling is minimized, so not as much floor space would be required to have 2 or 3 or 4 sets of fixtures. And then there's the cost. So some of the disadvantages of having an in-house burn-off might be that more thought for production scheduling, longer lead times. So if you are sending fixtures out to be cleaned, it's the outsource cost versus in-source, and then potentially more cleaning options may be needed along with more tooling may be required. So here's a calculation that was done some time ago, and this took into account that a painter had a burn-off oven in-house, and he ran that oven one time every single day. And you can kind of see as it goes through, I won't go through every single part, but basically he ran it one time every day, so 5 days per week at 50 weeks, 250 cycles. We took the total cost based on the amount of therms and the average runtime and the gas that was used. We added the labor, and when you add the labor, the loading, the unloading, the washing, the cleaning the ash, and then cleaning around the oven and the oven area, and you tally that all up based on the amount of wage that you pay the person and the burden rate at about $15 to $25 an hour, which may be low, we thought combined with the annual cost for gas consumption and the labor, that was approximately $48,000. And then there's the miscellaneous calculation of the ash, having a dumpster on hand, having it dumped about one time every quarter, the electricity to operate, the wash system, the oven repairs, the permits, and all those things. When you tally all those things up and you combine them up, we came up with another $9,000. Now again, this is your average size oven based on 250 cycles, 5 days a week. And we said that, in this case, based on 20 to 25 therms per hour or 22, that individual spent about $57,000 annually to clean and burn his hooks internally. So some of the things you want to look at when you're basically designing a best and basic design review, when you're designing fixtures, are the type of wire you might use. Now in the picture on the left, these are square on edge hooks. You'll notice that there's a definite V. And the best thing about the V is that no matter the geometry of the part, that part is always going to sit in the V, or the fulcrum, if you will. So the ground point is typically hidden and can run for more cycles. Now, if you look at the right side, there's kind of a CV hook, and those are used, those are kind of common, and then there's this S or Z type hook. Both of those are made of round material as opposed to the left. Now, the square on edge, in addition to the V, will also provide better grounding, longer lasting grounding, and provide better life and more revolutions around the line prior to stripping. Other ways that people paint are baskets, and the way that people wash products are baskets. So you'll see on the left there's a stainless steel basket. This may be used for washing parts down a wash conveyor prior to paint. On the right side, that was actually a fixture that was on a spin type system where they were dipping through a product or a process and painting the parts on a spinning action. Also, there are tree hooks. There are fixed tree hooks, and then there are adjustable tree hooks. You'll notice on the left that we're painting 10 parts on a very small tree. In this case, that particular tree doesn't have a lot of three-dimensional aspects to it, so it stores really well. It nests well. The ground point is hidden very well. There's a lot of good things about that fixture. To take it one step further, if you look at the picture on the right, we've got a stem, and we've got multiple crossbars. And you'll notice that some of the crossbars are different. If you go all the way to the top and you look at the first crossbar, there's about a dozen hooks on that top one. And if you come down, then there's 6 hooks, and then 6 hooks, and a dozen. And the reason I'm showing that is that with having a stem that has adjustable sockets, there's a lot of flexibility that can be gained. A person, for example, could take out every other crossbar and hang longer parts and not swap the entire fixture like on the picture on the left. So you could get really good efficiency by loading all those stems or all the crossbars in the stem and having every pocket loaded with a crossbar, or you could skip every one and have some versatility. The other thing I really like about this fixture is that you can break that fixture down. You'll notice on the left side of the right fixture, on each crossbar, there's a candy cane type looking hook. And those are there for a specific reason. If you took that all those crossbars off of that stem and you collected them in your hand and turned them 90 degrees to the same orientation as the stem is right now, it would take up very little space. So when it comes for cleaning and storing and all those type of things, this, by being able to break it down, can take up a lot less space and be more cost-effective solution for the average painter. Then we have robotic tooling. Robotic tooling is kind of challenging. We have to have very good, solid, repeatable fixtures. Most robots will paint plus or minus into a 1/4 inch in about a 5 foot by 5 foot window. The picture on the left is some mower decks that have to have repeatability from corner to corner within a 1/4 inch. Otherwise, the robot could crash. Some of the things that work with some of those type of fixtures are the carrier that's on the right to move those over to the line, get them in place for the product to be loaded onto the carriers themselves. Also, we have some frame tooling. Now, frame tooling, there is a need for it. Some of the advantages are that you could actually pick it up. 2 people could actually pick it up, and it won't waver, it won't bend, it won't sway around too much. Some of the disadvantages might be that you have basically 4 sides of a fixture that's going to get coating on it that you'll never reclaim, and you will have to strip and basically lose the paint that you're going to go ahead and apply that to. And these do not break down typically, although they could. And if they were, that would just help out the cause, because then if you did have them break down, the crossbars could be changed out and stripped more often than the frame, and the same would apply for that stem with the crossbars that we talked a couple of slides ago. And then we've got E-coat racking. The beauty about E-coat and racking with E-coating is that the parts can be loaded very, very densely. And that's a great thing. So for production and efficiency and throughput, this is a really good animal that some people don't take advantage of, but you got to have the right product mix for it. In a lot of cases where parts are like internal parts, they're not seen, they don't require that Class A finish, where you have a lot of volume of the same type of product. These fixtures in this process, you could have parts literally a 1/4 inch away from each other, and they're going to coat up as long as you keep the ground. The minute that you leave one spot empty and you try to go ahead and coat that product again the next time around, that fixture is going to be coated, therefore causing a reject and a no paint. Another method is chains. Not really recommended, but chains are used, and in some cases they have to be used on very, very heavy, large products. Some of the disadvantages of chains are basically that every link in the chain is a potential loss for ground. The other issue is that every link also wants to collect dirt and debris that potentially, when movement occurs, could break apart and then end up on the product. Also, we have specialty paint fixtures for larger parts. So these are parts that you typically would run in a batch type system. These are parts that are relatively heavy that need to be moved around, and a hoist isn't available. So there's a lot of this type of stuff. Typically where we see this is in wet type coatings. You know, sometimes not metal. The product that's on the very left is a fiberglass part. So that in this case, in that batch process, these work very well. Some of the disadvantages and things that people don't take into account are the casters. And wherever possible, if you are using some of these, I like to think of the 57 Chevy Bel Air, where we have fender skirts around the tires. If you can create little fender skirts to put around your tires, that will benefit you in the long run, as it'll let the wheels freely move for a long, long time. So let's talk about hook storage and ergonomics. So this is a case where a company had a lot of fixtures, and you can barely see the fixture. I'll show it in the next picture. But this particular customer actually stored a lot of S-type fixtures and clip-type fixtures in this basket. This basket was about 3 foot wide by about 6 foot long, and it was about 1 foot to 16 inches deep, and just loaded full of these products. The issue was that it went through a burn-off. And when it went through the burn-off, the ash had nowhere to go, so the ash stayed on the fixtures. And not only that, but when it was time to take the fixtures out of the basket, it was like a barrel of monkeys that you could hardly get one from the other. And I think you can kind of see what I'm saying here. But so the solution might be, in a case like this, if you are storing parts in a basket or in some other method other than maybe a carrier or a cart like this, you might help yourself by designing something this way. So that same basket of fixtures basically fit in another method where we were basically hanging hooks and these clips on a cart. We used the same amount of footprint, but we just turned it upside right. And now we've got a lot of advantages. Some of the advantages is the new cart holds as much as the current container, but it's about half the footprint and the same amount of the container again still. The other thing that I talked about, those barrel of monkeys, the result of that was basically it would take 3 hours of labor for people to dismantle and untangle all of those fixtures out of that basket, as opposed to now they can go ahead and they can grab them off every row or every rung as they see fit, and there's no detangling, and literally it takes no time whatsoever. The other thing is it gives process control. So if you think about this bar that these are all hanging on, if I know about how many of these clips or hooks would hang on that bar, I can estimate that if every one is full, I'm going to have X amount of these on hand. In the basket, nobody ever knew how many parts were ever there. So this helps in that as well. And the other thing is that it provided a cleaner result in ash because the ash was able to fall from the fixtures and it was able to clean, and they were able to spray them off and avoid that whole train wreck. So hook cleaning carts are a good thing wherever possible. People don't always take advantage of it. Yeah, I've seen people put hooks and racks along walls. They've put them in little bins. They've made little pegs along the wall or in between stands that are around their paint system. And I always say, why double handle anything? If I can handle something once as opposed to handling it many times, I'm going to be much more efficient. I'm going to save the company money, and I'm going to know exactly what I have at all times. So wherever possible, we want to try to use hook cleaning carts. And the other thing I see a lot of, or I have seen, is people who have grates typically store them like this. And I think about the poor guy who's got to lift these grates. Some of these can go 50 or more pounds. And just the ergonomics of it, when as opposed to doing something like this, I would say put them on a cart wherever possible. You get the chance to move them around. You don't have to wait for a forklift. Time is saved, energy is saved, and no one's going to break their back doing any movement. So some of the key points when I am looking at hook and rack design are basically the production. You know, how much production am I doing? Identify the largest piece to be painted, and we want to establish an envelope, and usually that's dictated by the washer or the smallest opening within the system. I want to prepare a part rack study, so I want to take a look at my top parts, and I want to do a study on what I have. Also, we should have, you know, how many shifts we're running that year, that day, how many hours we're running in a day. We want to take the physical dimensions of the part as they're hanging on the rack. We also want to look at the part surface area that's going to be coated and the part weight. Now, some of this is a little different from powder coating to e-coating, for example, because, again, with e-coating, we can get so much more throughput, and we really want to use and take advantage of that. So considerations for tooling, we want to minimize the part to the rack contact. And what I mean by that, if we go back to that V-hook, I want to minimize the contact point. And if I can do it wherever possible, I want to use that square on edge type material. I want to use some type of knife edge so that I only have one real small point as opposed to a round hook touching a round hole in the surface area that kind of goes along with that. So I really want to minimize that contact between the part and the rack. I also want to minimize the size of material. And in some cases, what I always say is that if I can hold a part with, like, let's say a 1/4 inch round hook out of mild steel, I probably can hold that same hook with either an 1/8 inch or maybe 3/16 stainless square bent on edge, because I'll have the same strength, but I'll get more revolutions. I'll create less shadows. I'm going to have a much, much better product if I can minimize that material and the contact point. Also, I want to group parts. I want to group as many parts. I want to take, if I'm building racking and I've got a brand new paint system, I want to take a look at the top 10, 20%, the 80-20 rule, however you want to say it. I want to take a look at those top running things. I want to lay those out. And I want to see what are the commonalities between them. And if we think about those tree racks that we looked at earlier, we can minimize really the amount of tooling and racking. In a case where you have those tree racks, wherever they can be used, if we can run 1 or 2 style stems and we can have just a minimum amount of different crossbars, I'm going to save boatloads of money in storage. I'm going to save in cleaning costs. I'm going to make it easier for my operators because they won't have to remember which fixture goes with which fixture. So I really, really want to take a lot of time and group those parts and minimize that tooling inventory. I also want to account for grounding. Again, I had talked about hiding the ground. If you can do that, great. If you can't, use the V-hook. Don't make round hooks. I see that so many times, and it's such an easy solution. It takes no less effort, and the cost is essentially the same. Also, I want to take into account storing and cleaning. When I am making fixtures and I'm not able to make those break down, and I'm not able to make the ideal fixture that I would like to, it's got to be a little three-dimensional. I got to take into account, how am I going to store that? Can I make that in a way that it's going to nest together very well? Can I make it that it stores like silverware in a drawer? I always say if you can do that, you can minimize the floor space and you can minimize your cleaning. Typically in a burn-off oven, you can utilize the whole space, but if the fixtures don't store, it could take 2 to 3 times the burn-off cycles that it would in one if you don't take time to do this. Also, we want to design to get the maximum amount of rotations. This kind of goes back to grounding. Again, we want to keep that ground. We want to keep it hidden. We want to do whatever we can to make that part fall into the same exact spot or ground out in the E-coat at the same point every single time. This will also help where you won't have operators using a Dremel tool to make a ground. So if we can do that every single time, take some account of it. We also want to look at filling the part window. So many times we see this where there's one part, we have a 4-foot space, so we've got a 4-foot opening, the part is 12 inches and we're not usually utilizing the whole space. The system, your paint system, doesn't care if it's got that 10% of the system being used or 100%. It's going to cost you the same amount of money to run it, so why not fill the window? Also, we want to use multi-tooling for maximum usage. So again, tree hooks, frame hooks, anything that you can do to avoid single hanging one part at a time, you should do it. And then we also want to take into account loading and unloading and making it easy for the operators so that they will be able to take the time and load the fixtures in a proper way. So here's an example of some loading and unloading. We've got some fixtures. This is for an E-coat system. So poor designs add to cost. So single hanging parts is a bad thing. Multiple connections or daisy chaining, that's potential loss of ground, and it takes a lot of time. There was a time study done a long time ago where we had a tree hook and we had somebody doing the same thing with doing daisy chaining, hooked apart, hooked apart, hooked apart, and the guy who had the tree rack won hands down. Overbuilding tool of excess of material. We want to minimize all the materials, so again, we're not painting racks, we're painting parts. Poor utilization of the window, we don't want to do that. S-hooks, if they got to be S, make them VV. Use of chains, we want to try to avoid that, and add-on type things, and then we don't want to leave the ground areas exposed. So here's a line per cost. We did this study a while ago where we took into account what is my cost per hour for the line, and these are the things that typically people would take into account when they're deciding and looking at how much does it cost me to run my line per hour. So with that, we took it one step further and said, okay, based on running 2 shifts per day, 5 days a week, and this many line hours per year, we had about a 92 to 94% yield, which is pretty good. But we said if we could increase our rack density by 20% by utilizing the right tooling, this is what would happen. We would save 90 line hours per year. We would have a rack density improvement that would be a total of $680 and 93 hours per year. And basically, we would save 83 hours per year. The total savings, if you take that in addition to the line cost per hour, $235,000 is what you would save by increasing by 20% and using proper rack density. So here are some case studies. Here we had the daisy chaining. I had talked a little bit about this. You can see on both the left and the right, we've got a hook apart, a hook apart, a hook apart. Again, not a great scenario. The solution would be to have tree hooks, or hooks where you've got even the hook that's at the very bottom on the very right, that has got a direct ground point from there all the way to the top, as opposed to that daisy chaining where you're probably losing ground by the time you get to the second or third part. Another example of this would be chains and add-ons. So on the left, we've got a hook that's got multiple chains. In this case, it looks like they used a dog chain. On the right, we've got the screw-in attachment that has a washer welded to it, which basically somebody has to take the time, screw that in, and then hook through that washer. The solutions in these cases were basically we got rid of the majority of the dog chain. We had one single link. We made it in a way that the single link would ground at the same point every single time. And on the other side, we got rid of the screwing method, and I had talked about hiding the ground. We put that basically up inside the part so it's grounding every single time. So the solutions in each case are basically we got rid of the single hanging methods. We got rid of the multiple connections between the parts. We used stainless steel materials. That's one thing I skipped over. But in those hooks on that where we got rid of all the dog chain and we made one single point, those are stainless steel hooks so we could minimize the material. The S-hooks were only used, but they're made of square bent on edge. We implemented the link hooks and eliminated the chains. That's where we got rid of that attachment. And then the hanging parts were basically designed where the grounding took place inside and hit the ground points. So the benefits to proper tooling is that the line density is improved, proper grounding provides better first-pass transfer, paint usage is reduced because you're not trying to overcome poor grounding by flooding the booth. Repeatable part presentation was achieved. We reduced the overall process to time work ratio, and we got rid of some of that non-value added labor, which kills the paint line every single time. The cleaning costs are reduced because, again, we're getting more revolutions around the line and we're minimizing the materials. And then the inventories of racks are reduced because we didn't need so many. The thing that was happening with the dog chain is that after one or two passes, it had to be taken out the line. So we needed 2 or 3 or 4 more sets in order to have enough so that we wouldn't run out between the burn-off cycles. So in review, I talked about these 5 things. I talked about rack cleaning considerations, the best and basic design review. We talked a little bit about hook storage and ergonomics, some of the key elements for designing racking, and then some case studies. So thank you very much. And next will be Larry Ensley with Hubbard Hall.
Thank you, Bill. Again, I'm Larry Ensley, and today I'll be talking to you about the importance of pre-treatment and maintaining a quality finish. Okay, I apologize about that. But before we get started, I want to talk about what are the results of having an inadequate pre-treatment process. What can you expect if you have a poor pre-treatment process? First of all, you're going to see parts defects, poor quality, unnecessary labor cost, bottlenecks in the system, rework, and scrap. All of these are going to result in lost dollars, unnecessary cost, and these are things that we don't want to see and we want to try to eliminate. So, since failure is not an option, first thing we have to realize is that cleanliness is the #1 issue you're facing when in a pre-treatment process. No matter how much work or preparation went into maintaining or making your part, all of this will be for naught if you do not address pre-cleaning or cleaning in your pre-treatment process. Doesn't matter if you're in aerospace, electronics, military, automotive, remanufacturing. All of these industries depend on having a clean part prior to pretreatment. Okay. To address this, we've come up with a checklist, a pre-treatment checklist. And we're going to discuss each one of these in detail. First, we'll talk about the parts themselves, the soil or the contaminant being removed from the part. Talk about we'll talk about the equipment, the chemistry, and the effects of that your pretreatment process has on the EH&S aspect of your process. Okay. First thing we need to do, we need to identify the part itself. You need to look at the shape of the part, the size of the part, how many parts are we running these in mass? Do you have lots of bends and twists like tubing? Do you have a lot of blind holes with intricate many facets? All this needs to be addressed when you're trying to determine what type of cleaning process to use. If you're running the same type of metal stamping over and over, we might look at a spray cleaning operation that's going through a multi-stage spray booth. If you've got multiple shapes or blind holes, we might want to look at an immersion process with ultrasonics. If it's a large, bulky item that doesn't fit in any of the spray wash systems, we may have to look at a manual spray wand type system. But all of these need to be addressed when you're getting ready to come up with a pretreatment process, and we need to discuss it early on. The next thing about the part we need to identify the substrate that your parts are made out of. It's very important that we determine whether we're working with steel, carbon steel, mild steel, stainless steel, aluminum, some of the softer metals like copper, zinc. Even in some instances, we're cleaning non-metallic surfaces such as plastics. But it's important that you determine what your substrate is going to be made out of, because if you're running aluminum parts, you don't want to use a very strong alkaline cleaner to do this. You're going to destroy your parts. Likewise, you may be running mixed metals, and we have to find a happy medium between the two, a mild alkaline cleaner to clean both surfaces. So that needs to be addressed as well. So we need to determine which type of cleaner we're going to use based on the substrate of your part. Okay. Next part of the checklist is the contaminant. We need to look at the type of contaminant on the surface of your part to determine what we need to remove. Are we removing oils and greases? Are we looking at the lubricants and the stearates? Sometimes these are very hard to remove. Oils and greases, typically you can use something mildly alkaline or high alkaline on steel parts and just remove this from the part. The surfactants tie the oils and greases up and pull it away from the surface. Stearates, that may not be the case. There are certain stearates that require acid environments or either extreme high temperatures to melt these stearates. This needs to be addressed going in. If you know you have this type of contaminant on the surface of your part. Could be a high carbon alloy that we need to discuss having the proper sequestering agents in your cleaner to tie up the carbon and pull it away from the surface of the part so that we don't cause paint adhesion problems later on in your process. It could be that there's metal particulates in on your parts, and we need to address this going into the cleaning operation. And we you may need to look at high pressure systems. We may need to look at ultrasonic cleaning. One of these methods may work best for you to clean these parts. The picture in the bottom right shows an example of some oxides that would be formed on a part after brazing prior to painting or powder coating. This would also need to be removed, and typically you're going to do that with, if you're going to do it chemically, it's going to be an acid. Some people do still use physical methods such as blasting prior to this step to get the oxide films off, but it needs to be removed prior to applying any type of top coat. Okay, that leads us to the equipment needs. Again, we're starting to maybe backtrack a little bit or overlap each other, but at this point, we've looked at our parts, we've looked at the contaminant being removed. Now we need to find the type of equipment that our parts are going to fit into. We mentioned metal stampings, or if your production process is running the same part over and over every day, this lends itself to a multi-stage system, something like your 5-stage, 6-stage spray, rinse, phosphate systems. That would be adequate for this type of operation. But you may have, like I mentioned earlier, parts that are very intricate, like tubing that have twists and bends that the cleaning operation can't get access to the oil or greases on the inside of tubing. That would lend itself more to the an immersion process with maybe ultrasonics or agilifts type systems to get the contaminants out of the interior of the parts. And I've seen many applications where you're running large bulky items such as truck cabs or large flanges for the oil industry. You may have to use a manual spray wand to clean and pre-treat your parts. You need to address this, know this going in when we're getting ready to establish a pre-treatment process. The next step in the checklist is the chemistry, and we're going to break this up into 3 parts. The first part I want to talk about is the cleaner, and step in determining what type of cleaner we need to choose. When looking at the cleaner, we need to go back to the substrate. Like I've mentioned, if you're cleaning aluminum wheels, you don't want to use a strong alkaline cleaner. You will destroy those. If we're trying to clean just mild steel stampings, we want an alkaline cleaner to cut the greases and the stamping lubes and to get the parts clean. After we determine what the substrate is, like we've mentioned, you also want to find a cleaner that's going to be able to remove the soil type you're looking at. If we're, again, I mentioned oils and lubes, you need to determine if it's going to be a mild alkaline cleaner. To clean both mild steel, it needs to be able to have the detergency to remove your soil from the surface of the part. Likewise, the third step in the choosing the right cleaner is the type of equipment. I mentioned that here because if you have a spray system, you don't want to use a foaming soap cleaner that will fill the building full of foam. And likewise, if you want to, if you're having an immersion process, you may want to have that foaming characteristic to lift the soil away from the surface of the part and pull it in the solution. You also need to determine at this point whether your cleaner is going to split the oils and contaminants away from the part to be filtered or removed with an oil coalescer, or do you want to have the cleaner to emulsify these soils and hold them in the solution? That needs to be determined here as well. The next type of chemistry we will talk about is the pre-paint itself. People ask, why do we need pre-paint if the parts are clean? Well, this step in the process will improve your paint adhesion, your corrosion protection, and it's going to give you better salt spray results. The panels on the right here show they're at the same step in the process. They're the ASTM D1654 paint adhesion step. The part at the top has had a good zirconium pre-treatment. The one at the bottom is just a simple iron phosphate process. And you see the difference in the paint adhesion at the same amount of hours. Your paint is flaking off on the bottom where it's not on the top. Now, with pre-paint, there are several options. You've still got your iron phosphates, which are very predominant in the industry. Many people are still using those. They're workhorses. They're fairly durable. Some of the drawbacks, they do create a substantial amount of sludge in solution. They require heat to run. Typically, it's around 140 degrees Fahrenheit. plus or minus 10 degrees Fahrenheit, and you're going to get somewhere in the neighborhood of 30 to 70 milligrams per square inch coating weight when you use an iron phosphate. I also mentioned zinc phosphates here. There's still a niche in the pre-paint industry with zinc. In the heavy equipment, sometimes in the military, you'll see this. The drawback is it does take heat, much more heat, and it builds up a substantial amount of sludge that has to be removed from the tank. But I just want to mention it briefly because it is out there. But what I'm going to focus on mostly today will be the zirconium pretreatments. It's a phosphate-free product. It runs at room temperature. It's based on the nanocrystals, so you don't use coating weight to measure this. It's almost unmeasurable. You'd have to have a very sensitive measuring device. But it's clean chemistry. It gives you very good paint adhesion, corrosion protection, and it's becoming more and more predominant in the industry today. Some of the 5 tangible benefits that we know for using zirconium. You've got the reduction in energy, reduced sludge, less wastewater, improved performance, and less contact time. The benefits of having this, if you can reduce your energy, you're going to lower your heating costs and your energy costs. Like I said, you can get a good crystal structure at room temperature with zirconium where you have to heat the iron phosphate. Less sludge. Anybody that's running a multi-stage iron phosphate line knows that you have to go in from time to time and do maintenance on the risers and the nozzles and go in and scrape and clean your cleaner tanks to get the buildup of sludge out. This happens with iron phosphates and zinc phosphates, but you do not. The sludge is minimal at best with zirconium. And we mentioned wastewater issues. One of the biggest issues today is phosphates being regulated in your wastewater. Because there's zero phosphate in the zirconium system, you can avoid these costly surcharges. So we can reduce the wastewater costs that you incur. And we mentioned that you're getting an improved corrosion protection and paint adhesion by using zirconium. The crystal structure lends itself to a much tighter crystal. They're smaller, so you're tighter together, and it's a more tight fit, so there's less exposure to the bare metal. So you have better corrosion protection and more sites for paint adhesion. So this gives you a competitive advantage over your competitors who are not using zirconium. And because there's less contact time required, you can increase your productivity. An iron phosphate process requires between 30 and 60 seconds to get a good crystal structure or on the surface of the part for paint adhesion. A zirconium process takes between 15 and 30 seconds to get the same crystal formation on the surface of the part. So you can increase your productivity simply by switching to zirconium. You can double the capacity in the line feasibly. Talk about the seal nets. Why would you use a seal in a pretreatment line? Typically, this is done to promote paint adhesion, especially after an iron phosphate. The military specs still require a chromate seal over zinc phosphates. There is a strong push to get away from this by the military. They're testing very aggressively to get away from this and move toward non-chrome or trichrome seals, but they are still being used. Iron phosphates require this to get better paint adhesion and corrosion protection. And it's also, seals are used at the end of a multi-stage line or after a manual spray line to prevent corrosion going to the next step. Now, these seals can be your typical organic seals such as non-chrome, some quaternary amines, something like this. I've even seen zirconiums used as a seal over iron phosphates, and the use of chromates is still there. It's mandated. Typically, it's going to be military or aerospace, but they are still there, and then we need to be aware of those. But those are the reasons you would use a seal at the end of the line. Now, I'll show this picture right here for our EH&S part of the checklist. This is a satellite photo of Lake Erie. I think it's in 2013. It shows an algae bloom viewed from space in Lake Erie, and all of this algae growth was attributed to an excess amount of phosphates coming in from the Maumee River, creating this toxic algae bloom. This is the reason phosphates are being regulated, pushed away, trying to get away from. You'll hear this, phosphate-free cleaners in your home detergents and your industrial cleaners. They want to get away from phosphates, and your large users are definitely pushing to go towards zirconium, and that's how that affects your EH&S. I'd like to thank you. Thank you very much. And if you have any questions.
Well, thanks, Larry. Thanks both Larry and Bill. Very informative presentation today. Very well done, guys. I appreciate that. At this time, we will take any questions you have for them. They'll be happy to. We'll take a few minutes and answer. If you want to type those questions into your question box, you can submit them right now. Also on the screen, you will see is our Bill and Larry's contact information. If you don't want to ask a question here, you can contact them through their email. By the way, this presentation will be on Products Finishing Magazine's website, pfonline.com, where we will have this presentation. So if you want to go back and review anything that that they have talked about. And again, if you want to ask some questions, we'll take a few right now. Actually, the first one I will throw out here is this may be for Bill. Bill, how often or when should I clean my fixtures?
Okay, so how often? I can't tell you how many times that I've been asked that. Really it's different for everyone. So we've got the guy who's a powder coater, and we've got the guy who does wet coatings, and we've got the guy that does e-coat. And so the guy who does e-coat does a really good job. He puts a part on every single hook. He covers the entire fixture. The part grounds out at the same exact spot every single time. And so because of that, and the fact that e-coat will not build up paint once it has a coating on the fixture, that fixture can run a really, really long time. We've got some cases where some people may only strip their fixtures one time a month. In some cases longer, in some cases shorter. The guy who does wet coatings, he kind of has almost the same thing, but it's a little reverse. So because he doesn't have to ground, he doesn't have to worry about the grounding as much in some cases. Sometimes he does, but sometimes he doesn't. But in either case, usually the parts are typically a little heavier, and the parts can go around many times, or the hooks can go around many times, and therefore he doesn't have to strip maybe 1 or 2 times a month. But the guy who's powder coating, who doesn't do a great job, who doesn't allow his part to sit into the same spot every single time, he may have to strip his after every single revolution. So it's really different for everybody. Again, it kind of dials down into how well their parts ground, what type of their product mix they have, and basically that's my answer. I hope it helps.
Great. Yes, no problem with that. I think this question is going to go to Larry. The question is, the zirconium and iron phosphates are used for steels, but not for aluminum alloys. So,
not true. Zirconium is present on both metals. I've got many customers using it on both substrates. It's actually, zirconium is a little more forgiving than your iron phosphates, because if you're processing aluminum using an iron phosphate process, there needs to be fluoride present in that solution to get the same bite. Zirconium does not have that problem. You can use the same chemistry for both iron, or for both steel and aluminum.
Okay, Great. Again, if you have a question, you can type it right in there to your, the question box should be on your screen. Next question, I think this is going to go to Bill again. Is there a benefit to using stainless steel hooks versus mild steel?
You know, in most cases, yes. And the reason being is, again, I go back to the tensile strength. You know, when you have, let's say, a 3/16 or 1/4 inch mild steel hook, you know, chances are, and if it's round, chances are you could bump that down to maybe, you know, 1/8 inch. You could bump it down to 1/16 inch size. And what that does is it creates a lot less surface area for the hook. And by having less surface area, you're basically not painting so much paint on the hook. You're actually getting paint where it belongs onto the part. So stainless steel for increased tensile strength and for the possibility of reduced diameter and overall surface area, yes.
Okay, great. Well, I tell you, we probably have time for one more question here. We're kind of getting up to the top of the hour. Question is, again, tubular steel can add to strength in paint fixtures, but is it a good idea to use tube steel?
You know, if someone can achieve very good drainability, then I would say yes. The thing you want to avoid, though, is to have closed ends on tubes, because no matter how good the weld is, typically, eventually those welds are going to create pinholes. And typically what happens in any system, whether it's E-coat, powder, whatever, you know, the minute you go to cure that part on that tubular fixture, a lot of times what will happen in those closed tubes is that the chemistry inside or whatever has gotten inside, any of the condensation, will eventually start spewing out and shooting out of that fixture and land onto the parts, creating part rejects. And the other thing I've seen is that eventually they get so plugged up when they go to a burn-off oven, which can get up to 800-900 degrees. A lot of times they end up coming out of that burn-off oven kind of looking like the exploding cigar on the cartoon. So that's not a good thing.
Not a good thing.
If you can drain it, yes. And the other thing I'll say too is if you can make it round. So by making it round, you're going to get a little less of flat surface area for paint to build up, and you'll get more blow-by with whatever coating it is that you're using to not have that fixture build up with paint so greatly.
Gotcha. Great. Well, I think that's about enough time we have for questions. Again, if you wanted to contact Bill or Larry, there's their emails right there. Again, we want to, you can contact them directly, and I'm sure they're going to be happy to get right back with you. Again, we want to thank our sponsors for today's webinar, Therma-Tron-X and Hubbard Hall. Again, thanks to Bill and Larry for joining us today. A really great presentation of the first part of this 3-part series that we're going to be having. Part 2 will be held in July, Tuesday, July 18th. It's going to be at 2 o'clock. It's going to be, the topic will be drying, cooling, and curing technologies. And so if you want to sign up for that, you would go to ccaiweb.com at ccaiweb.com, or you could sign up for that presentation. Again, Bill, Larry, thank you very much.
Thank you.
Yep.
You're welcome.
Great. And thanks you for joining us, everyone, and have a great afternoon.